So now we're going to look at simplifying and combining radical expressions. Okay, so we're going to start off with kind of the textbook definition of a square root. Bless you. Say the number b is a square root of the number a if b squared equals a. So in other words, the number multiplied to itself is equal to whatever your root value is. So for example, if you have square root of 25. Okay. So we know that 5 times 5 is 25. We also know that negative 5 times negative 5 is 25. So negative 5 times negative 5 is 25. So that means square root of 25 is equal to 5. And square root of 25 is equal to negative 5. Or if you want to just combine them both together, square root of 25 is equal to positive or negative 5. So that little plus minus just means either positive or negative will make that true. Okay, so what if we had, say, square root of 49? We know that 7 times 7 is 49. And same thing with negative 7 times negative 7. Times negative 7 equals 49. So we went ahead and put those two together. Square root of 49 is equal to positive or negative 7. Okay, so any number multiplied to itself will give you your square root. Okay. Now, if you see numbers like let's say 1, 4, 9, 16, 25, 36, 49, 64, etc., and so on, those are called perfect squares. Let me clean that up a little. Okay. Now the reason they're called perfect squares is because if you look at each of them, 1 squared is equal to 1. 2 squared is equal to 4. 3 squared is equal to 9. 4 squared is equal to 16. 5 squared is equal to 25. 6 squared is equal to 36, and so forth, and so on and so on. Okay, so that's why they're called perfect squares. Which you'll hear that term a lot today. Okay, any questions so far? All right, I'll leave that up for a few seconds. Thank you. Okay, it looks like everyone's, oh, almost. Okay. Like everyone's all caught up. Okay, now if you remember, which you should, it was like 2 minutes ago, square root of 25 equals positive or negative 5. Because 5 times 5 is 25, or negative 5 times negative 5 is 25. But what if you had square root of negative 25? Yep, that's where you get into the complex numbers. Okay, but here you can't say 5 times 5 because that will give you positive 25. You can't say negative 5 and negative 5 because that will still give you positive 25. So this one actually has no real solution. To a negative square root. Okay. Now that doesn't mean that a solution doesn't exist. It just doesn't exist on a real number line. When we get into complex numbers, that's when we'll start to solve these. Okay, so if you have square root of negative 25, the only way this will be able to be solved in real numbers is if you get the absolute value of that negative 25. Okay, so then the absolute value of negative 25 is just 25. So if you have the square root of 25, that's when you'll get your plus or minus 5. Okay. So that means that if you do have a negative number, it would have to be the absolute value of that negative number. That's the only way you'll be able to solve that one. Okay, so that means that x squared would have to be the absolute value. Okay, so any questions on that one? All right. So x squared has to be positive. Okay, so any questions on that so far? All right, so now we're going to kind of look at notation.
So within that, though, it could still be negative x squared because the absolute value would turn it into a positive.
Exactly. Yeah. Okay. So let's say if we have square root of 100. Okay. That just means any number multiplied to itself would give you 100. That's going to be your answer. Nope, that'd be plus or minus 10. Okay. Now, whenever you see a square root and there's no number here, square root of 100, it's assumed that there's a 2 there, which means you're going to multiply a number to itself, well, basically twice, to give you the number that's under here. And that 2 right there is called your index. Okay, so we know that 10, if you multiply it to itself twice, will give you 100. And negative 10, if you multiply it twice, will give you 100. But what if you had a 3 there. That just means what number multiplied to itself 3 times will give you 8. And in this case, it's just 2 times 2 times 2. So the cube root of 8 is equal to, since 2 times 2 times 2 equals 8.
Can we just put, like, for on the test, we can just write 2, we don't have to indicate?
Oh, no, you don't have to put that part. On the test, it won't be that easy.
Yeah, I know. That's wishful thinking.
All right, so this index here really just says what number multiplied to itself 3 times bring that up a little bit equals 8. Now there's one big difference between square roots and roots that are basically odd. Is that when you have an odd root, you can find the cubic root of a negative number. If it's even, you can't, because no two numbers will multiply to give you a negative number. But what if you had, or wanted to find, bring this up a little bit. There we go. What if you want to find the cube root of negative 8? You can actually find that because negative 2 times negative 2 times negative 2 will give you negative 8. Okay, so that's equal to negative 2, since negative 2 times negative 2 times negative 2 would actually give you your negative 8. Same thing if you had the cube root of negative 27. Negative 3 times negative 3 times negative 3 will give you negative 27. So you have negative 3 times negative 3 times negative 3 equals negative 27. Does that make sense? Yes.
The outside number is called the index, but what's the inside number called?
That is your, I should know this. I've said it a million times before. Not your radicand. Yep, your radicand. It is radicand. Yep, you're welcome. Just realized my Monday morning brain is still going on. Yep, so this is your radicand. Let me draw an arrow to it. There we go. Okay, so that will lead us to our general notation. Yep. So in general, we know that if you have just the square root symbol, that's your square root. But if you have an index of 3, that's called your cube root. And anything higher than that is just the number. So this would just be the fourth root. Then you have your fifth root. And it just keeps going and going and going and going, until you get to what they refer to as your nth root, which is basically just wherever you decide to make n. Where n is equal to your index. Okay, so like we saw before, whenever that index is even, your radicand has to be positive. So when your index is even, your root value must be positive. Okay, and we saw that with, let's say if you had the fourth root of 16. I mean, some number multiplied to itself 4 times will have to give you 16. Which in this case would be 2 times 2 times 2 times 2. So 2 multiplied to itself 4 times will give you 16. Okay. But if you had the fourth root of negative 16, oh, forgot to put my negative. That would make a difference. Okay. That one you wouldn't be able to solve with 2 or negative 2. So this one would just be no real solution. Okay. So that's if you have an even index. If you have an odd index, you'd actually be able to solve, or possibly solve, a negative root value. Okay. So when your index is odd, say a real solution can exist. Okay, so that's like if we have, for example, the cube root of 64 is just 4 times 4 times 4, which multiplied to itself 3 times is 64. So that's just 4. Again, because 4 times 4 times 4 is 64. And let's say if we have the cube root of negative 64. In that case, negative 4 times negative 4 times negative 4 will give you negative 64. So that cube root is negative 4. Negative 4 equals negative 64. So these are just kind of reinforcing why they are true. All right. So any questions on that so far?
I do for the even index,
Sure.
where 4 is the square root of negative 16. How come before when you showed us the absolute value, you can't like change it into that and then be able to solve it?
If the absolute value was already there, you could solve it.
But you
Yeah,
can't.
you can't just add it, because then you're changing the whole thing.
Okay, fair enough.
All right. You're welcome. Okay. Any other questions on that one? All right, I'll leave that up for a few more seconds. so now we're going to review your rules of exponents. Okay, I'm sure you've gone over these, but it's probably been a while, so we'll just kind of refresh your memory. Okay, so first, we're going to go with the product rule. Okay, which means that if you have x to the power of m times x to the power of n, that's just x to the m plus n. Okay, so for example, if you had x to the 5th power times x to the 4th power, that's just going to be x to the 5 plus 4, which is x to the 9th. Or if you had 3 to the 5th times 3 to the 4th, that'll be just be 3 to the 9th power. Okay, so we have our power rule. And that's if you have some value raised to an exponent, and both of those are raised to another exponent. Then you're just going to multiply those exponents together. Okay, so for example, if you had, say, y squared and raise that to the 4th power. Okay, so whenever you have two exponents, you're just going to multiply those together. So it's just y to the 2 times 4. Which is y to the 8th power. Okay, so now we're going to go to the power of a product rule. Okay, which means if you have two values multiplied and they're both raised to, let's say, the power of m, then you're going to just distribute that exponent. So that's x to the power of m times y to the power of m. Okay, so let's say if you have, for example, 2y to the 4th power. You're just going to distribute that exponent. So it'll be 2 to the 4th power times y to the 4th power. And we know that 2 times 2 times 2 times 2 is just 16. So that would be 16y to the 4th power. Okay, so now we're going to look at the quotient rule. Which is similar to the product rule, but it just applies to quotients. Okay, so if you have x to the m divided by x to the n, then that's just x to the m minus n. Okay, so for example, if you have 2 to the 12th power over 2 to the 10th power. Okay. As long as your bases are the same, you can just subtract your exponents. So that's 2 to the 12 minus 10, which is 2 squared, which is just 4. Now we've had the power of a product. Now we're going to go over the power of a quotient, which is pretty similar. You just distribute the exponent. Okay, so for the power of a quotient, you have x over y, let's say, to the power of m. It's just x to the power of m over y to the power of m. Kind of clean up that q a little. There we go. Okay, so for example, if you had 3/4 and you raise that to the 4th power. Bring that up some. Okay. Then you're just going to distribute that exponent. So you have 3 to the 4th over 4 to the 4th power. Okay, so 3 times 3 times 3 times 3 is 81. And 4 times 4 times 4 times 4 is 256. Okay, and then you have exponents of 0 and 1. Bring that up a little. Where anything raised to the power of 0 is just going to equal 1. And anything raised to the 1st power is just going to be that number. So x to the 1 equals x. So let's say if you had 4 over 5 to the power of 0, that's just going to be 1. Or if you had 4 over 5 to the 1st power, that's just going to be 4 over 5. And I have one more. I'll continue that on the next page. I'll leave that up for a second. And it's going to shut off